Alright, good morning. Today we're going to advance ourselves a little bit and look at how things from space get to the Earth and how they interact with one another once they're here. So when we talk about this, everything's going to start with the sun. In our case, the sun is going to be the most central source of energy that we have here on Earth. It's going to be renewable, it's going to be sustainable, it's going to be something that's constant throughout our lifetimes. When we look at the sun, the first thing that we think about is the light that comes from the sun. But to be more specific, we call these electromagnetic waves. Now, those electromagnetic waves travel at the speed of light, which is 3.0 times 10 to the negative 8 meters per second, which is important because that speed allows it to have a constant fuel, a constant source, and we are constantly exposed to it. Now, when we look at the different types of waves, we have 7. They go from radio waves all the way down to gamma rays. Now, I would freeze frame this, or I would copy it down to make sure that you have those in order and understand how they change. Because here in the radio waves, we have very, very large wavelengths. And we're going to see a big swoop on our graphs. They're long, they're spread out, and they're lower energy. That makes them safer and less dangerous for us as humans, meaning they don't damage us. But as you go down the spectrum, what you're going to find out is that after the UV, the X-ray, and the gamma rays, you're going to have a much tighter bundle of wavelengths. They're going to be much shorter, and that's going to make them higher energy. So, lower energy over here from radio to gamma, where it's going to be higher energy. The higher that energy gets, the more dangerous that they are. We all know that UV rays are something that cause damage to us from the sun. But we also know that X-rays can damage us. That's why we wear lead vests to protect us. And that gamma rays are radioactive and can cause things like cancer, burns, and some other things as well. Now, what's important to note is that even though these are dangerous, they are reflected partially by the Earth's atmosphere. And one of the most important things about that atmosphere is that it allows us to have a shield, a protective force that keeps us from getting as much damage from these as we otherwise would. Now, tomorrow we will talk about how that force field is put in place and how that atmospheric shield works. But until then, I want to focus on heat that comes from the sun, because that heat is also something that sustains us. That heat is something that keeps us alive. That heat comes from a process called nuclear fusion. Now, on the surface of the sun, what you see is that there's a high capacity for both hydrogen and helium atoms. The hydrogen atoms, through heat and pressure, are fused to form a helium atom. And what that causes is a decrease in mass. So a decrease in mass, an increase in energy, and an increase in temperature. So the formation of helium is going to increase all of those things, which allows us to have the energy and light that we use on a daily basis. However, there's also a process that goes backwards. It goes from a larger atom to a smaller atom. And we call that nuclear fission. Fission would take this atom, helium, and break it into its core components. We use this for nuclear reactors, as well as for things like atom bombs and hydrogen bombs. The more that we look at these electromagnetic waves, the more we'll see how they impact our lives. We'll look at photosynthesis, we'll look at magnetism, and we'll look at renewable energies as we move throughout this semester.